Okay. Awesome. Okay. I'll hand over to you, Bhargav. Should be able to share your screen and so on.
Great. Nice one. Yeah, excited to be doing this. The first thing I'm going to be doing is just dropping a link in the chat for a Google Colab notebook for you to copy. It says copy this. Yes, just like make a copy for yourself so that you can edit it without any problems. Yeah, so I'll give like a little before I share my screen and so on, I'll just give a little like very high level like what's going to be going on in this tutorial. So my background is weird. I'm a computer scientist and sociologist. Used to be in academia and then now kind of in the think tank world. So this tutorial was originally a introduction to computational social science tutorial. So it was very much kind of aimed at beginners in the social sciences and humanities who are looking to learn how to code, right? So that's the kind of framing. The framing definitely comes from a more academic background, trying to get people up to using computational social science. So you'll see a lot of references to computational social science in the in the tutorial. But what that means more like specifically here is basically text and network analysis. That's basically what we'll be focusing on, as well as a little bit about how to use LLMs through Python. It's funny because I wrote the first version of this tutorial 5 years ago in 2020 for a PyCon conference. There's Python conferences on that was on computational social science, and it's wild how much I've been doing Python, NLP, programming, machine learning, deep learning for about a decade now, and it's really wild how much has changed from like 2013 to 2018 and 2018 to now. It's been like really paradigm shifts. So going through this tutorial is also fun for me because like, whoa, so much has changed in even just like in 5 years. Like so much has changed in the way I program and code and use these kinds of tools. So, but one thing which remains constant is, the fundamentals stay the same. And quite often it's just useful to know the basics before getting into, I guess, like 2025 computational social science, which is different from what it was, back when I wrote this. So the tutorial itself hasn't changed dramatically from 2020, though I've added a section on large language models and how to use them in Python. So that's the context. If honestly, even if you don't know any Python, I'm going to try and do it in a way where at least you get the vibes of like what's possible, what's not possible. Yeah, so that's what we'll be doing. So yeah, hope you all have the link. I'm gonna start sharing my scroll. Actually, before I start, any kind of thoughts, questions, anything? Cool. Well, and also like feel free, we'll keep it. I'll be walking through some bits of code, but there's comments here and there, and there's enough kind of descriptive text around the code to figure it out. I guess you could also, if you want, like post tutorial, try to understand something you don't know, copy paste the code into ChatGPT and be like, what's going on here? And ChatGPT is actually really good with explaining code to you. So that's one tip. Yeah, so it's let's get started. Cool. So now you see the Google Colab. There's a lot of text. I was just kind of writing it out for myself, honestly. But basically it's a lot of what I just told you that, it's going to be we're going to move past kind of graphs, move past tables and numbers and move into text and networks. So, it gets kind of funky, right? Like we're moving into more abstract territory of texts and networks. But there's very relevant questions from, there's a kind of like theoretical field of computational social science. And then, there's questions which are very practical for today. For example, how have right-wing talking points evolved over the last decade? How have people's political preference changed in the context of social media? Horribly. But what are conservative funding networks like? these are three like very, these are three examples of questions that are very relevant for progressive movements, which can be answered using text and network analysis. So again, if someone's done some kind of text and network analysis, this might seem a little basic, though you might still learn, something which you might not know in the past. But a lot of it is just very basic text and network analysis and data cleaning and data organization. Data cleaning and organization is what allows you to actually do the data science. Um, half, like literally half the job is basically cleaning and organizing and finding your data. So in the notebook I have the small bit on what computational social science is. It's basically, if any of you are social scientists, it's any of those, but use data and computing. Now I don't want to go off into a rabbit hole, but there's slightly two different schools here. There's one school which is kind of grounded in theory and qualitative work and uses these computational social science techniques to kind of bolster their work. And then there's a slightly more kind of tech bro approach, which is just like let the numbers speak for themselves. My training is in computer science, but I'm very much a believer of theory grounded, questions grounded analysis. So, but that's just, that's a whole, can go off into a whole different thing over there. What's really changed though is basically availability of data, scraping, and being able to collect data, and also having, GPUs, tensor processing units. We basically have the ability to process large amounts of data, which couldn't be done before. Like mathematical sociology and network science and all this kind of stuff was always around. But now we can actually do it. And you can also do it like using a tiny notebook like this, which is incredible. I mean, this kind of work has been around for 50, 60 years, but the fact that we can do this so easily is what really turns everything around. Um, Cool. I might actually just ask, is there any kind of questions or doubts? Sorry if the kind of social science aspect is if someone's not from that background, it might be a bit um, you might be wondering what exactly is that. A kind of another way of thinking about it is, humans communicate through language and through relationships. So it's basically tracking and understanding language and relationships. So it's another way of thinking about it. I chucked some text in here. There's a bunch of textbooks and all that kind of jazz around this. Again, this is not going to be like theoretical or academic, but this is kind of where a lot of these ideas come from, and then they can be really translated to other hacky stuff. So, what are we going to be doing in this specific notebook? Well, when I wrote this tutorial 5 years ago, I just finished watching Bend It Like Beckham. The Indo-British film from the early 2000s. I'm Indian or, I'm from India, so I was super into it back then. I found the text, I found the transcript, basically, the entire, um, oh damn, the link's not here now anymore. Okay, well, so if you want to download the transcript, you can go to the original code and repository over here. This five-year-old GitHub repository that has a link to the entire transcript. So the transcript is, I mean, well, it's really, it's literally the transcript of the film, right? So yeah, I just managed to find an easy download of this. And yeah, so the first thing which I did was I downloaded that and then I uploaded it into Google Colab, which you can do over here, benedictbeckham.txt. So that's our data set today. Now, this isn't in itself a progressive leftist policy data set, but the idea is more to show you what text and networks can do to you, right? What you can do with text and networks. So also, yeah, spoilers. If you haven't seen the film, you're gonna have spoilers. Sorry about that. Cool. So that's basically the idea. We're gonna see what we can analyze using a movie script. And the thing is, a movie script is quite similar to other situations. For example, say you want a parliament transcripts, right? So you're analyzing what's happened in the House of Commons. Say you have a transcript of an interview between an evil corporation and a corrupt government member, whatever. Whatever it is, this kind of data source, a transcript, can come up quite often. So, but this is a bit more wholesome. I mean, world's really depressing, so I thought this would be a nicer one to do. Now, in terms of the packages we'll be using, NumPy is a really popular, um, basically numerical processing package. SpaCy is for natural language processing. GenSim is for some useful for something called topic modeling. Topic modeling is basically identifying you have a large corpus of text, say newspapers or whatever it is. You can identify the underlying topics in text without actually having to specify what they are. It's an example of what's called unsupervised learning, which basically means you don't need to tell the algorithm what's inside, you just get the answers. It's kind of old school now. It was, more popular in 2010s, but it's still useful to know that it exists because it also contextualizes the power of what you can do with LLMs, large language models today. So these are the packages. And pandas is kind of data organization package. So we're going to import these bad boys. I'm going to just more or less, just pressing shift and enter for all of this, right? So this is just going to get some text going. And the first thing is we're going to open the text up and then we're going to see what it's like. And yeah, so it's like I said, just basically text. So you have later at soccer field, girls watching boys. He's so tick man in it. Anyway, he's taking the shirt off. Okay. But yeah, so it's a bunch of teenagers talking football. So, this is what the text looks like. Give me an idea what it looks like. How many, so we separated each different line as a different text. So there's 1,600 lines here. And, checking out like this, we can see the first text, 23rd text, 25th text. So it's basically strings like this, right? David Beckham, blah, blah, whatever. So what I'm going to do now is basically try and make some structure or sense out of this unstructured, chaotic text. And the way I'm going to be doing that is trying to, because the way the text is structured, luckily for us, it's basically the character followed by a semicolon and then colon and then the text, right? Can you hurry? I'm telling you about that girl's a first class bitch. That's funny. But yeah, so we're going to basically use this, split the lines up like this, and store all the characters and texts. So now what we have is basically character counts. So like how often are certain characters coming up and what are the texts associated with that character? And then all the extras from the film, which we don't really care about. And then so now let's look at the character counts. So we have we have John only shows up twice, Gary, Alan, but then you have Jess, one of the main characters, shows up 191 times, Pinky 37 times, and so on. So this kind of data structure called a dictionary allows you to map who the character is and how often they're showing up, right? This is useful to do things like, oh, also, I get a little fun fact. It's still there's 15 times in which a song's being played because that also shows the song playing. So yeah, so now we have all of these characters linked to the character texts, right? So we have all the characters from the film extracted. The way we extracted is because the data set was structured in a kind of straightforward way. Now, what we want to do now is basically see, can we find can we identify scenes and like transitions between scenes? When I was going through the script, I noticed there were lots of locations like, at shop, or like mobile phone rings. And, these are kind of like transitions in a sense, right? They're moving from one scene to the other. You have to kind of, you have to have a bit of flexibility or you kind of make the rules up as you go along based on the task you're trying to do, right? So based on that, made this little bit of code to identify locations and transitions. I use these as my transition words, like at, then, later, in, outside, these kind of transition words. And I also assign some as a key character if they appeared as a separate line in the text more than 25 times. So this way I can identify key characters and all these locations. And then I get this nice little list of Punjabi song playing. Yeah, so I get this nice little data set of transitions, scenes, and key characters. So I have all these. So we just have 7 key characters here, 7, 8 key characters. Family, football coach, mom, dad. So now the next thing which would be useful to know is what are the texts just associated with the key characters, right? And this bit of code basically goes through it. If the character is a key character, add them in. If not, don't add them in. Pretty straightforward. And then we look at the key characters and how many times each of them is spoken. Jess is the main character, has the most number of lines, and then the rest of the lines. So this is already pretty cool in the sense that we went from like a raw movie script to characters and the lines associated with the characters. So here, using this dictionary, sorry, I can also imagine this might be fast for, is this, so just doing a temperature check. Is this okay? Is this speed kind? Yeah, cool. I see some nodding, so I'm just going to go ahead. Feel free to interrupt me if it's not. So yeah, now I'm looking at key character Jess. I'm sick of this sweating and it hasn't even started. I can relate to that. So yeah, so these are Jess's lines basically, and this is useful. You'll see it a bit later on if you want to identify who's similar, who's different, and so on. And uh, what we're going to do now is try and now that we have all of these key characters and we also have these locations and transitions, we have an opportunity to find out who shares screen time, who are in the same scene together, basically. And this allows us to, identify a network. This allows us to create a network by identifying, now, of course, you can have all kinds of network. And an example of what a network is are like a protein-protein interaction network. If you're doing biology work, two proteins are in the same. I'm not a protein person, but you get the idea. They're binding together. You have air transportation networks. If a flight's going from one airport to the other, that's an idea of like an edge. The edge is the flight going, and the nodes are the two airports. And then in our case, social networks, which, for example, again, this was written in the time where Twitter data was easy to get. So a lot of the examples here were Twitter. Now it's not easy to get Twitter data, but you could identify networks of retweeting and things like that. There's a really cool Python package called NetworkX, which one of my friends is a core contributor to. Yeah, it's a really neat package where you can do different kinds of basic and advanced network analysis. So let's create a character graph, right? So first, let's create an empty graph for every character and all the key characters. Add a node, which is add this character in. And then now I have all of these scenes, and then I'm going to try and see for each scene, and then I break them up based on those transitions, as you saw in the previous bit of code. We're going to basically split the character and the text, and we're going to see which characters are in which scenes and which key characters are in which scenes. That's why you have some of these empty ones. It's because it didn't have any key characters. And so you have now this really interesting little bit of data actually, where you see in each scene what's going on. Who are the key characters? Some of them have multiple characters, some of them just one or two. So this is again a useful data set which helps us construct this network, which we're going to look at in a second. So what we're going to do is, for every scene, if the scene has more than one character, we're going to add an edge between those characters. This basically allows us to construct this association network, right? So basically logic is if there's character one in the scene, if character's two in the scene, then just add an edge. It's like literally character add edge. And if they've appeared more than one time, just plus one it. So it becomes a thicker edge. And then now you have this, neat little graph where you can basically see, who's been in the most number of scenes together. Now here it looks like more or less everybody's been in a scene with everybody. So it seems like, okay, this isn't super interesting. But then you can go a little deeper and you can start to get this weight, you can start to see between, say, Jess and Pinky, how many times they end up in the same scene. It's 48 times. So this allows us to attach a weight, and then we can start to visualize it and do this little heat map here, which you can see. So, looking at this heat map, you can see that Jess, main character, has appeared in a bunch of scenes with almost everybody. And then you have Jules's mom, who's not in a lot of scenes. So, this kind of visualization of the network allows us to see who's interacting with who. If I pause and take this in a progressive context, and you think of who's funding who, and you see, who funds Palantir, who funds Raytheon, who funds all these crooks, and you can start to have these networks of associations. So, drawing parallels to potential movements. Now, the cool thing about Network X is you can identify things like network centrality, which basically shows who is the most like central character in this network, and you get a score. So over here, you get a score saying Jess, again, main characters. She's in scenes with everybody. And then you have Tony, who is not in many scenes. So, you have this kind of distribution of how central they are in the network. Again, we went from like literally just a movie script to a network of association in not crazy complicated code. So this is an example of the kind of power you can do with networks, network analysis. A shout out to some of the work done at the ADU, the Autonomy Data Unit. Some of the work we've done at networks of funding, for example, also use network analysis. So networks, as a way of showing associations and relationships, and then you can also add characters and flavors to the network. What kind of relationship are they? So really powerful social scientific tool if you're using like research, but also really cool tool just to identify what people are getting up to. I mean, given that, yeah. So I really like networks as a way of understanding social data and making sense of things. Like this graph tells you a lot of who's friends with who and who's not. And it's also, going from unstructured data to a structured kind of setting like this is it's quite powerful. So cool. The catch up, we create a graph of we create a graph which maps how characters share a screen with each other. This allows us to visualize how often characters appear with each other, centralities, and so on. And then you identify the central characters. So yeah, pretty straightforward code and setup, and we can do a lot. Now, one final bit on graphs and networks here. I want to find, it's tough to see if there's any cliques or groups or stronger relations just looking at this graph with everyone connected to each other. So I can make a smaller graph by saying, only if they've appeared more than 25 times in the same scene, create an edge. Otherwise, don't create the edge. Call it a stricter graph. So you can see here, if the edges are more than 25, then you add an edge to the stricter graph. And then now I see that Jules's mom is not close friends with anyone. Sucks for Jules's mom. Everyone else is homie. Everyone else are homies here. And yeah, Jess again is right in the center. She's appeared in more than 25 scenes with every character. Makes sense. Jess's mom and Jess's dad hang out. Good for them. Healthy family, I hope. So yeah, so you can kind of see how you can, tease out different aspects of social relationships by having a limit on the weight of the graph or, based on what you want to do. A note here that, we used quite a simple thing over here, which is just the number of times they were in the same scene. You can do some really advanced stuff with graphs and networks. For example, you can also say what kind of relationship are they having, positive or negative, and you can play around with things like this as well. There's an entire graph and network analysis is a pretty intense field with a lot of literature and cool positive examples. You can imagine it's also how like Facebook used to do recommendations, like, oh, you're a friend of a friend of a friend. So, there's a lot of utility to graphs and networks beyond looking at movie scripts, as you can imagine. I'm happy to chat about that in the end if you have some time. I do see we're about halfway through. So cool. So that's it on the graphs and networks for now. I can, I'm happy to, if you reach out to me, I'm happy to point you towards more advanced graphs and networks, literature or just coding resources. NetworkX has a lot of really powerful inbuilt tools. And then there's a lot of like more advanced things like link prediction, clustering nodes, like you can try and there's so many cool things you can do with graphs and networks. Um, there's especially in the context of machine learning and deep learning, there's just a lot you can do. For example, you can also do things like who is most like based on previous interactions, can you predict who is going to form a new link? You can even do stuff like that if you have enough data of past interactions in a completely new data set. So there was especially a lot of academic research done on this between like 2015 to 2022 before large language models became super hot. Deep graph learning, deep network learning, which is like a part of machine learning and deep learning, is a really interesting field. But I think a lot of scope, especially for kind of progressive analysis, given that a lot of our a lot of the people we don't like tend to be buddies with each other. That allows us to, we can identify such networks. So I'm gonna maybe pause for like 5 seconds for any like hands up, thoughts, questions, etc. Before I move on to text.
I just ask a super basic question. Um, just because the only Python that I've learned is in just using terminal on Mac, and I presume they do similar things. This one is just sort of cloud-based, but do you recommend using this instead of terminal, or there are different functions? Because I have the data set that I need to work with is stuff that I've downloaded, that probably would take up a lot of space if I put it back up.
Cool. No, that's a great question. I would say that for if you're analyzing like the primary use of this kind of cloud platform is for me to share it, right? Share
Okay.
it and allow others to kind of copy paste and use it freely and just allow it to be a resource. But for any kind of serious programming in say you're working with hundreds or thousands of data points, a terminal is, quite often you're running scripts from the terminal.
Yeah.
I really like notebooks. So this is an online version of a notebook. There's also a kind of more similar to a terminal. They're called Jupyter notebooks, which you run. The cool thing about them is, for example, over here, right? Say I want to be, say I first do 50 over here.
Uh,
And then I run it, and then I'm like, oh, but this is not very useful. So I want to change it to 25, and then I run it again. I just did that like in 3 seconds. Whereas if you have to do everything on terminal, then you have to like go into the terminal, change the thing, run it again. Like, so if you're prototyping, trying to figure out how you want your code to be, my workflow, and maybe Lucas, if you're in the chat, you can maybe say a few words on this. My workflow is usually I first do it on not on cloud, but I have a local version of this. So this is a cloud-based version of this Jupyter, of a notebook, Python notebook. I have a local version of a notebook that I use for all kinds of prototyping. And it's incredibly useful for prototyping because if you want to make a quick change, see an output, you don't like it, change it back, run it again. Yeah, I mean, like notebooks have started to become popular 2013, 14, and it like truly changed my life. It's like, yeah, it's super useful in that context. But when I want to run something for 100,000 PDFs, for example, notebooks are slower. That's the trade-off. They don't have, it's a GUI, right? At the end of the day, there's a latency in printing something. It just takes time to do that. So if you
yeah.
want something to happen with a large batch under the hood, behind the scenes, it's through a terminal on Python, which is, but you would be running scripts, right? Scripts like do a specific thing again and again. If you want to have like this kind of flexibility, these kinds of notebooks, I cannot recommend them enough.
So you'd use this sort of thing for testing to make sure that your code is extracting the right sort of stuff. Then once you know it's doing the proper thing, and then you might move to like a notebook to like batch test like 10 to 100 of the things, and then when you want to jump to the 100,000 PDFs, that's the sort of workflow you'd say.
Yeah, I would
Okay,
say
cool.
that. And it does depend on like for example, no one in industry is like necessarily using notebooks to run anything in production. So I know those are kind of buzzwords, but like, if you want anything with like quick response or even like, if, like large batches, you would often use something like just Python and terminal. But
Okay.
for prototyping, you'd be using this.
Super helpful. Thanks.
No problem. Cool. I'm gonna kind of hustle because there's 25 minutes. But a lot of the work here is to kind of understand, I guess, the setup. So we're gonna now do text analysis. We'll be using, I have some, you'll see in the link over here, I have some other material. Also, if you just go to that link, you have like all of my notebooks, which I've made public. Again, a lot of them are a bit dated now, given how quickly the field's moved on. But we'll be doing something called topic modeling. Topic modeling, again, like I said earlier, allows us to identify kind of keywords, key topics. So again, in the interest of time, I'm not going to walk through in detail necessarily like all of what's going on here, but I'm basically cleaning the text, getting rid of stop words. Stop words are words that don't have any kind of strong semantic meaning, like is, there, what, how, those kinds of words. If it's punctuation, if it's numbers, I get rid of all of these because they're not useful for identifying broader topics in tech. And the reason I want to identify topics, I guess I want to see what are people talking about in this film, what are their motivations, and so on. So after I clean the text, it says, "Come downstairs, my sister's going crazy," is likely what the original sentence was, but then it gets broken up into just the keywords, as you see over here. This kind of setup, and then I use a little dictionary to translate it into to number, because that's what the algorithm understands. And then I run this algorithm called the LDA model, which is a kind of topic modeling algorithm. I'm actually going to take a second to while this is running in the background over here. It's still running because it's doing 500 passes. What topic modeling does, and this, I remember this is from the original paper. I don't know if it's clear. Okay. So what topic modeling does is if you have like, cool. If you have a document and you want to identify what are the key topics within this document, you can think of every topic as a distribution of words and every document as a distribution of topics. This is kind of a setup. Now, the reason why this is useful is you don't need to mention what the topics are to the algorithm. You just mention the number of topics that you think are in the whole corpus. So for a newspaper, like say you have 10 years of newspaper, normally this is done for science. It's done for like, if you want to see how different topics in science have changed over time, different topic in it. Basically, if you want to see how topics change over time in a large body of text, this is very useful. And GenSim is the package that does this. Now, with large language models, admittedly, maybe some of this is a little outdated, but it's still worth knowing. Don't forget your elders, something. But this used to be really in vogue. I mean, this algorithm came out 2003, was really popular, I would say, until like 2016, 2017, 18. Still used, but you'll see over here how exactly it's used. Okay, so it's being trained, and then I've already run it previously. So what you end up seeing is when I print the topics look like this: 0 to 5, 0, 1, 2, 3, 4. And then you have, each topic is basically a collection of words, right? So here it's want, play, good, football, it's about playing football. Hot, come, Joe, it's about how hot Joe is. This topic is about Beckham. This topic is about Jess. This topic is about mom and dad. So you kind of, and the movie's actually about like how hot these teenage guys are, football, and mom and dad. So this is actually a pretty decent topic extraction. It's fairly juvenile film. But what this helps with over here is we just told the algorithm identify the number of topics in the text, and it basically spat out these topics, looking at what kind of words end up appearing in what kinds of documents. Here, the document is like one line from the movie script. So it basically goes through every line in the movie script and then sees what kind of words are people saying. So, I could do like a whole tutorial on just topic models, so I won't get into that. But what's useful here is basically linking a topic to a character from the film, right? So then you can kind of, structure, now I'm going to move on to networks and topics. You can now structure people based on what they were saying. There's a really cool paper here about, it's called Individuals, Institutions, and Innovation in the Debates of the French Revolution. And it basically talks about how Yeah, just basically how the debates during the discussions during the French Revolution, how they were distributed by topic and how like what kind of topics came out on top and so on. So that's a good example. I mean, that's a it's a sociology paper using data science methods, using these topic models to come up with a really, it's a pretty in-depth analysis. Cool paper. Again, now it seems a little dated. It's crazy. This is 2018, right? Like, and it was absolutely cutting edge. I mean, PNAS is a top journal, so it was cutting edge when it came out. This paper uses topic models. So the same thing I'm just using right now. Like 7 years ago, this was state of the art in terms of computational text methods. Not so much anymore, but things move fast. But it's still very useful to know that this exists, right? That you can identify topics just from a broad corpus of text, not knowing what what it's made out of, and then now associating individuals to topics. So this chunky little bit of code over here cleans every key character's associated texts, feeds them into a topic model, the one which we just created, and then attaches that back to the character. So it basically gives characters topics, right? What that basically means is that Jess mostly uses words 30%. So again, here the number 30% of Jess is from topic 0, 20% of Jess is from topic 1, and then the rest of the topics topic 4. So you can kind of get a distribution of topics, which is a distribution of words for each character. This basically allows us to assign it's basically like, okay, Will mostly talks about 4-day work week, data, and autonomous Marxists, for example, right? You can like break it up, and then you can break up everybody in a different kind of topic distribution, because we're just floating distributions of words, aren't we? But yeah, I mean, I'm being slightly facetious, but it's very useful if you want to analyze semantic content and people's actions and you can go further and you can identify like similarities and differences and so on. So there's some really cool things which you can do using these kinds of topics. Fake news, sorry, Will. Cool.
Matt's got a hand up.
Yeah.
Does it work? This also sounds a bit dumb, but does it work for number values? Like, say I'm trying to extract, a fine or something that like a number in a text and what that represents. Is that very similar? Like whatever's
Yeah,
after the
actually.
pound sign, you can create a
Yes, you
protocol or
can.
something or whatever.
Yes, you can. Yes, you absolutely can. Though I would, it's in some way I could have maybe upgraded this tutorial to include a concept called embeddings, which are more using neural networks, which kind of upended this kind of analysis back in the day. So could be an idea for the next tutorial. But basically, you can use maybe Matt, it would be good to have an email chat, or I think I've even seen you around Pelican House, so maybe we can
Yeah,
just chat.
I'm in 307, so let's have lunch and
Okay,
I
yeah,
can pick your brain because I'm trying to learn this stuff uh for a specific project, but it's quite slow going given I know shit all.
Yeah, I'm happy to help. I mean, there's like for context, a large part of my master's and PhD was basically teaching social scientists how to use these kinds of tools. So you're my primary audience, and basically your question I think is better suited to using word embeddings, which is that's like another level of advanced even related to this. So it's a really useful and powerful tool, and there's a lot of really interesting social science research and also you know, humanities research using these word embeddings and neural embeddings. Basically, you can cluster things, identify context and meaning, see which words appear around which words more often. There's a whole wide world of textual analysis out there. But in the context of just this tutorial, what do we do then with these topic proportions, right? What do we do? We now know that, again, this is quite abstract, right? Like it says the coach uses 30% of topic 0, and topic 0 is about football and playing. It's funny, I'm wondering who uses the one about like the hot boys the most. Anyway, cool. So we're now going to try and see if we can use these topics to identify, before we were looking at network relations, which is how often do people appear in the same scene. But then this still tells us nothing about whether they're talking the same language, whether they're getting along with each other, and so on, right? Now, to do this kind of stuff, we can use topic models. And here in this bit of code, I'm basically using a technique called, it's within a discipline called information theory. And in information theory, you can identify how similar or different are two distributions. And here you have each character is linked to a distribution of topics. So you can basically, in a nutshell, you can say how similar are the topics these characters are talking about. That's basically what we can identify using this technique from information theory. It's called the Kullback-Leibler technique. Lucas, if you're still around, as physics, it's like basically it comes from physics and math, really. But it's useful in this kind of situation because we're looking at these distributions. So then, boom, I create this little graph, this heat map where you can see over here, where 0 means they're very similar. And if they're farther away, the number is higher and it's brighter. So basically, Jules's mom has nothing in common with anybody. Sucks for Jules's mom, right? But Jess, she's vibing with like everybody here. She has a high similarity metric with everyone, which makes sense because, she's kind of controlling the conversations. Again, this is a like coming of age teenage film, right? So there's not going to be a lot of really deep insights you can drag, but you can see the potential here. You can basically identify how similar or different characters' speech. That's very, very powerful. You can imagine an extension of this to Parliament and see which kind of politicians are using the same language. Sadly, all politicians are using the same language, which sucks for us, but it opens this kind of opens the way for us to do deeper research, just looking at both networks of association, but also networks of textual content. And that's really powerful. So the last time I did this tutorial, it ended here. Lucky for y'all, we're going to have a little 5-minute session using large language models now. So what does turbocharging this with large language models looks like? I'm going to import this OpenAI information. Now I have this little secret OpenAI API key, which y'all are not going to see. Everyone, so if you have an OpenAI account, what you can do is basically, if you ever use something like ChatGPT, you're typing in text and you have this interface and back and forth. What you can use using Python is you can automate this process. You can automate this process by sending multiple queries. For example, if you have 100,000 PDFs, you can ask 100,000 queries, right? And the way this is done is using this API key, which, you need to set up the account. There's a couple of tutorials online that specifically go into how to set up these API keys. But now basically you can see I've had this client over here, an OpenAI client, passed in this API key. And then let's look at Jess's character text. So I want to basically ask ChatGPT to analyze this, right? And let's see so the kind of question I'm specifically asking is, these are the system instructions I'm giving to ChatGPT. You're a film analysis assistant. Your task is to read the provided movie script excerpt just for the given character and extract structured insights. Return a response as a valid JSON with exactly the following keys: character, so extract the character, relations, who are the other characters this character is talking to, and what are the key themes of this character. Pretty complex question. And in the past, 5 years ago, like a sucker, I was using topic models to identify these themes, right? I was identifying these topics and then reading them manually and then trying to figure out, okay, does this make sense? All of this and given that this normally, you have the worry of hallucinations, which is an absolute real thing, if you give unstructured information to the model. But if you're very structured, very clear about what you want to extract, ChatGPT actually does a pretty great job, especially the latest models. So over here, then the prompt I'm feeding the model is analyze the following movie script for this character, begin the script text, and script, extract the key relations and the main themes in 1 to 3 sentences, and return the script as a valid JSON. And then, I'm the client, passing it what's going on under the hood is it's basically talking to ChatGPT under the hood, specifically this model. And then it's passing this kind of text, giving this very, very structured information to get it back. Yeah, so this is what the call is doing. And then I wrote this little helper script for me to go through every single character one by one. So like 4 character in the characters, run this for that character. And then afterwards, I want to clean the response because, ChatGPT is going to give you like a bunch of messed up, funny text. I want to make sure that I have the characters, relations, and themes, as you can see here, like nice and clearly structured. That's what this function is doing. So you often do have to write these helper functions around it. You can't just spit it in, spit it out. But boom, let's run it. And I'm basically going through each of the main characters. So that's each of these characters here, right? Jess, Pinky, Jules, her mom, so on and so forth. And I'm passing in like this much text. It's not loads, but it's reasonably significant. Very, very structured instructions. And let's see what it did. Yeah, characters, relations. Jess, as we expected, is related to everybody. And then the themes are cultural expectations, pursuit of passion, gender roles, family dynamics, identity. Hot boys doesn't somehow come up here, though the movie's literally so much about that. But yeah, as you can see, well, sexual identity, that's interesting. Anyway, so yeah, so this is I mean, you can get like pretty complex response of the character relations, themes, one by one for each of the characters by using ChatGPT and passing it like this. This kind of kicks topic modeling in the butt, if you ask me. But the thing is, you still have to deal with the uncertainty of large language models. The thing with topic models and embeddings, the other method I talked about earlier, they require you to do the interpretation a lot more. I mean, normally I suggest people to use mixed methods. Don't just use large language models or don't just use topic models or embeddings or networks. Use all of them. And you would get similar complementary insights, right? There isn't one kind of assessment, but you can get really cool complementary insights. And you can you can do a lot with this basically. I mean, since I've had access to this kind of API, what you've just basically seen. Again, here it's again like the film script doesn't really the really thorny questions, it's not very clear what you can ask. But I'm not putting it mildly when I've said this has completely changed the way I do my work. I mean, it's a really, really exciting time to have access to these kinds of models. And yeah, it's really, really powerful. At the ADU, at the data unit, yeah, we use these a lot alongside, the more traditional methods of network analysis and text analysis, data scraping, and all that good stuff. But this has really changed the game, in my opinion. There's, caveats again. The more open-ended your prompt is, the more likely ChatGPT is to mess it up. But the clearer you are, and if, for example, one of the projects we're working on is a lot of PDFs. This PDF has structured information, and we ask it to extract very very clear structured information. It's great at that in a way which previous tools were not able to do. So this is an example of, yeah, it's really powerful. And we've covered a lot here, right? Basically data scraping, organization, structuring, all those dictionaries and all that early on. That's really the major part, right? Like making sure you map every character to all of its texts. I know it took me a long time to actually come up with the code to do that in the first place. And then everything else comes easily after that. But then, so basically data organization, scraping, and structuring is 80% of your job. Garbage in, garbage out. So that part really needs to be done well. But then after that, if depending on how creative you are, really, you can either use networks, topics, large language models like this. And, this is just the surface. This is like very much an introduction to the kind of social scientific data analysis using these machine learning tools. There's literally textbooks, journals, like so much in the last 5 years It's a very rich field with a lot of cool stuff. Unfortunately, a lot of the right and are using this kind of stuff to do, a lot of their stuff. So yeah, it's about time we skill up and use these tools ourselves. So that's it really. You have the link to this tutorial, so feel free to use it. And like I said, there's a lot more to it than just this. So feel free to reach out. Yeah, I'm gonna stop sharing and maybe give some time for just kind of questions, thoughts, etc. Yeah, thanks. Thank you very much.
Thanks, Bhargav. We'll open up for questions. Christian, do you mean the Python beginner tutorial? Yes.
Yeah, yeah. Or whatever ones you've done before. I'm just interested in, yeah, watching them back.
Yeah, cool. I'll get you a link for that. I'll whack it in the channel now.
Yeah, Dave.
Hi, that was great. Thank you. I'm gonna lower my hand. Just wondering from like a perspective of say you have like a network in mind that you want to identify or something like that, and you've got like an idea of what data you might want to use. How do you go about like structuring the way you like? Because obviously you did like quite a few different things here, and it seems like you could have done them in different orders with like different weights, etc. How do you decide on a method that like stands up to like scrutiny, if that makes sense, or like avoids your own bias and things like that? Or is there like a cookbook you can follow to like apply these algorithms in this order, or is it more like context dependent, etc.?
Good question. Do you mean in the context of like networks specifically or like in general?
Yeah, kind of in general, or like I guess sorry, that's not helpful that it is in general, but yeah, in general.
No, it makes sense. I mean, like, well, there is like no real like right way necessarily. It's largely because, you know, for some kind of historical context, a lot of these tools were basically made by like profit-seeking companies to get more like clicks on their ads and stuff like that, right? Like that was kind of that's where all of these tools come from. And yeah, basically the world of business really, and like large scale data analysis and all of that. Now, what they're optimizing for is, well, their bottom line or, whatever their business problem is. Social scientists have started using these tools more recently, I would say like, post 2010s, right? And everyone has kind of a different take on it. There's also like fierce fights within the community on like what the right way is, and there's a bunch of different situations and contexts. So that's not very helpful, but what I can point you to if you send me an email is some like classic textbooks in this field. And I also think that it kind of depends on what you want to do. For example, at ADU, we're not necessarily writing social science pieces, right? If you're writing a social science piece, then you want to be engaging with the theory in your discipline. Like within network science and like network theory, there's a whole bunch of social network analysis, and they all have different schools of thought and what a social network is and is not. If you're just, if you're trying to do more expose a certain connection or relation, then it's up to you to decide how you want to do it. So it's really winging it. I mean, absolute experts in the field are totally winging it. So yeah.
Awesome. No, that makes sense. I guess it's such a complicated problem. Each one is different, right? So yeah, that makes sense. But yeah, no, thank you. That's really helpful.
So, anything else for Bhargav? All right. Well, if there's nothing else, then I guess just for me to say thanks, Bhargav. Thanks for that. This is recorded, as I said, so we'll upload this. You can watch this back. And there will be, as I said in the comments, that's the one thing I did forget. There will be a third session of this where we're going to go through some of Autonomy's recent, well, I don't know how recent back catalogue and we'll have a member of the ADU, whether it's Bhargav or Lucas or Sean, talk through some of those projects. You can see some more of this stuff in a different use, basically. Bhargav, anything else you want to say?
No, yeah, just yeah, thanks for coming. Hope it was useful. Sorry if it was like intimidating and a lot. It's kind of yeah, how it was kind of set up was to slightly intimidate you, but really it's easy once you start like yeah, once you start getting into the stuff. And also with ChatGPT as a code assistant, even if you're not, you can do like a decent amount by just, hacking around basically. So, and also really feel, I'll drop my email in the chat, just my personal email. And yeah, feel free to reach out to me and I can like point you to things. Yeah, thanks for coming.
Thanks, everyone. Have a good evening. Have a good rest of your week.
Thanks so much. See ya.
Cheers, guys.
Thank you.